Let's say we have the piecewise defined function f of x that's defined as x cubed plus 5 over the closed interval 3 pi over 2 to 5 pi over 2 and defined as tangent of x outside of this interval. So between negative infinity and 3 pi over 2 exclusive of 3 pi over 2, as well as between 5 pi over 2 to positive infinity exclusive of 5 pi over 2. And we want to show that f of x is continuous over the closed interval 3 pi over 2 to 5 pi over 2. So let's first look at the open interval 3 pi over 2 to 5 pi over 2. So this is everything in this closed interval, but excluding the endpoints x equals 3 pi over 2 and x equals 5 pi over 2. In this open interval, we are only dealing with this polynomial function x cubed plus 5. And x cubed plus 5, if we had this function g of x equals x cubed plus 5, that's going to be continuous for all values of x. If we restrict it to this open interval here, 3 pi over 2 to 5 pi over 2, it's still going to be continuous for all points in this interval. But what about at the endpoints? Well, the issue here is that right at 3 pi over 2, we have the function is defined as x cubed plus 5, but to all points immediately to the left of 3 pi over 2, this function is defined at tangent of x, and tangent experiences a vertical asymptote at x equals 3 pi over 2, and really every odd integer multiple of pi over 2. So the limit as x approaches 3 pi over 2 from the left of f of x does not exist. But the limit as x approaches 3 pi over 2, let me bring this down. And as x approaches, there should be a 3 here. 3 pi over 2 from the right of f of x. Well, that's going to be the function value of this value at the function value at 3 pi over 2, which is 3 pi over 2 the quantity cubed plus 5. So this is going to be 3 pi over 2 cubed plus 5. Now what about at the right end point? Well, the limit as right at the right end point, this function is defined as, well, that right end point cubed plus 5, so 5 pi over 2 the quantity cubed plus 5. But when we look immediately to the right of the right end point, we're defined as tangent of x, and note that at x equals 5 pi over 2, tangent of x experiences a vertical asymptote. So the limit as x approaches 5 pi over 2 coming in from the left, so this would be for x values greater than, let's say this is 5 pi over 2 here. Well, right, for x values greater than 5 pi over 2, this function does not, since there's a vertical asymptote, you know that on either side of every odd multiple of pi over 2, the tangent function's either creeping up towards positive infinity or creeping up from negative infinity. So on the right side of a vertical asymptote, this tangent function is actually going to be right at negative infinity. So this limit does not exist. Limit coming in from the left, or the limit coming in from the right does not exist. So it would be approaching negative infinity, and so that function is not converging to a particular number. But coming in from the left, we're still in polynomial territory here. So the limit as x approaches 5 pi over 2 from the left of f of x, that's going to be equal to the function value at 5 pi over 2. So 5 pi over 2 cubed plus 5. Okay, so we know we're discontinuous at the endpoints, but that is not required for continuity on a closed interval. For continuity on a closed interval, we need continuity over this open interval as well as right continuity at the left endpoint, which we do have. Because look, the limit as x approaches 3 pi over 2 from the right is equal to the function value at 3 pi over 2, which is the left endpoint. And we also need left continuity at the right endpoint, which we also have. The limit as x approaches 5 pi over 2 from the left of f of x is equal to the function value at 5 pi over 2. So the limit as x approaches the right endpoint from the left is equal to the function value at the right endpoint. So we have left continuity at the right endpoint. So because we have continuity over the corresponding open interval, right continuity at the left endpoint, and left continuity at the right endpoint, then we know f of x is continuous over this closed interval here, 3 pi over 2 to 5 pi over 2.